two exercises today. One is using Pythagoras theorem to solve two-dimensional problems, as well as three-dimensional problems. We'll do it in one lesson. Yeah, I just did that. Yeah. Yeah, it's easy. We did two last lesson. No, I don't think so. Well, you don't know. Okay, let's go through. Example 1. That means we have more time for revision before the test. All right. Example 1, applying Pythagoras theorem. Let's look at this diagram. Two skyscrapers are 25 meters apart. That's shown there. A cable links the tops of the two buildings. Find the length of the cable. If the buildings are 50 and 80 meters high, you have to find, what do you have to find? Find the length of the cable. So what that tells me, that if you subtract 80 by 50, there's a difference of 30. Yeah, it's so easy way to draw a diagram. Let's do that. So you got 25. Let's for C for cable. So you write C square equal to 25 square plus 30 square. All right, so we use Pythagoras. Now you need a calculator. If you don't have a calculator, please borrow one now. I've got some here. Right. Okay, let's work this out. So you go 25 square plus 30 square equal 1525. And you get square root of this, correct to 2 decimal places.
Josh is trying to take the thing off the table. It's a crime to put paint on wood.
Okay, we'll talk about it later. 39.05. 10. But it's 2 decimal places. Yeah, 2 decimal place. 2 decimal place. So if it's 2 decimal place, you look at the third digit. If it's 1 decimal place, that will be 39.1. Get it? Alright, that's the length of the cable. Any question? Alright, let's move on to the next page. Next page. All got it? Three-dimensional problem. Okay. Yep. Okay, let's go through this. The length of the diagonal of the base of a rectangular prism is 5.3. That's the diagonal there. The height is 3.9. Find the distance from one corner of the rectangular prism to the opposite corner. Okay, so this is actually the longest stick that you can put inside a rectangular prism. Do you agree? So if you want to find what's the longest stick you can put in there, that's the length you can find. So to find out the longest stick, you can use Pythagoras again. C square equal 5.3 square plus 3.9 square. Use your calculator. All right, that's good. Okay, so if you did it, that's excellent. 43.3. Yes, you do. Correct to 2 decimal places. Well, if the questions say leave in surf form, that's what you write. You stop there. Does that make sense? Only when they say in surf form. This is not surf form. They want 2 decimal places. So you square root your answer. That will be 6.58. Correct to 2 decimal places. Right, pretty easy with the three-dimensional problems. Right, are you ready for example 2? All right. Okay, let's go through this. It's actually quite easy. All right, watch this. I will show you. The longest stick, as I said before, is the line connecting from one corner to the opposite corner. That's the longest stick, right? Now to find this, I need to find the other side. Find this side first. Let's find A. So if I draw this, it's 2 by 10. You have to find the length of A. So you have to go A square.
So the answer is 12.3.
Watching 10 square plus 2 square, 104. So find the length of the diagonal at the base first, and then you go square root of 104. Just leave it like that. Do not need to calculate A. Leave it in exact form. Yep. Okay, well, it's not just the answer. Let's go through the working out. Then you look at this triangle. So I draw the triangle on the top. So you have a green side, you have the red side, and the side here. Now I'm showing you. That's your A, which is root 104. You have to find out C. Does that make sense? So I drew the bottom triangle first, which is, you got it? Okay. So, yeah. All right, let's work out this triangle. Again, use Pythagoras again. C squared equal root 104 squared plus 7 squared. Notice that when I square the square root, I go back to, yeah, it just gets rid of it. So what do you get? 153. Then you square root your answer. And what do you get? All right, 12.36 or 12.37. 12.37. That's the longest stick you can, because it's approximately equal. I've rounded my answer to that place. No, but it's better you do it because you rounded the answer. They are not really equal. They are approximately equal. You get 153. All right. Hang on.